11-1 Square Roots and Irrational Numbers, Part 1.
The objective today is to find the square root of a given number and to classify real numbers. Now, square roots can be a little bit confusing, Gabby, so if you get a little confused, it's okay. Okay, so what is the definition of a square root? An operation that yields a number which, when multiplied by itself, produces the given number. So the given number is the number you see. So you're looking for a number that multiplies itself to be 16. So you'd say this as the square root of 16. Do you know?
I think it would be 1.
So 1 times 1
times 1 it would be 16.
I don't think 1 times 1 is 16. I think 1 times 1 is 1.
Oh, 16 times 1 is 16.
But I'm looking for a number times itself.
Times itself, that means 16 times 16.
No, that means 4. 4 times 4 is 16. You remember that? No? Oh, we got to work on your multiplication.
Uh-oh.
It's okay. So, the square root of 16 is 4.
What's the dot?
The dot is another way of saying multiply. When you get older, we get away from the little x's. And we do dots or we do parentheses. Good question.
Ew.
So, if a is greater than or equal to 0 and a squared equals b, then a is the square root of b. Don't worry about that. So a perfect square is the square of an integer. So basically that means a perfect square is any number that has a factor that multiplied by itself gives you that number. So what that means is like 625. That's a perfect square because 25 times 25 is 625. You don't have to memorize that one.
Well, yeah, no.
And 15 times 15 is 225. So 225 is a perfect square. 20 times 20 is 400. So 400 is a perfect square.
36.
Do you know what number times itself is equal to 36? We practiced those last week.
6.
6 times 6 is 36.
Yes!
Yes! And then we have 49. That's a perfect square because 7 times 7. And there's an infinite amount of perfect squares. 9 times 9.
81.
Yep. All right. Sorry. So perfect squares. Let's practice some. So 0 is a perfect square. Because 0 times 0 is 0.
Oh, yeah.
The square root of 0 is 0.
Oh, yeah, it's 0.
Okay. And then 1 squared means 1 times 1. And that's 1. And the square root of 1 is 1. 2 squared is 4. Square root of 4 is, do you know what it is, Gab?
4.
Nope.
2. 2. Is that?
Do you know what 3 squared is? What's 3 times 3?
9.
Okay. What's the square root of 9?
3. So it's like fact family, sort of.
Yeah, very similar, yes. Very similar. Okay, so 4 squared? Just did that one?
8.
No, that's 4 times 2.
2.
What's 4 times 4?
4 times 4, 16.
Okay. And what's the square root of 16?
4.
And 5 squared?
So it's 5 times 5? 25.
Very good. And 6 squared? We just did that. Did it last week, remember?
6 times what?
6 times 6 is
48.
No, that's 6 times 8, goofball.
30?
36. 7 squared means 7 times 7.
7 times 7.
That's 49. 8 squared is 8 times 8, which is 64.
Why don't they have square roots?
Well, because I'm going to make them write that here in a second. They're going to have to do that on their own. So on your chart, please fill out the chart and finish it up.
This can go on forever.
Kind of like cruise when we're talking about airplanes, right? Yeah. Okay. Every positive number has 2 roots. It has a positive square root and a negative square root.
I like positive.
I know you do.
I like
Let me tell you,
being
my
positive.
students don't like negatives either. They're not big fans of the negatives. So the positive square root is the one that we're going to deal with most of the time, but there is a negative square root. So the square root of 16 is 4, and then we can also have a negative square root of 16, which is negative 4, because negative 4 times negative 4 is a positive 16. The square root is not the inverse of the square, because it only gives the positive root. Sometimes people treat it as the inverse, but it's really not. And I know you're probably not totally understanding that right now, and that's okay. So I just want you to kind of get you to listen to it, and for you guys to just kind of let that soak in a bit.
So it's like the square's root or something?
I'm not sure what your question is. Okay, then let's move on. Okay, think about the following. We have x squared equals 100. Well, that can either be 10 or negative 10, because 10 times 10 is 100. You know that one, right?
Yeah, doesn't most people know it because it's just 10 times 10?
Yeah, most people do. And then we have negative 10 times negative 10 is also 100.
So x equals 100 times?
No, don't worry about it too much. Okay, so then we have x equals the square root of 100. So that has two solutions. The square root has only one solution. So they're not the inverse. That's basically what I'm trying to get at. And again, just kind of let it sit in your back of your brain. It's not something you have to totally get right now.
Oh, yeah.
Okay. So, we're going to determine what two consecutive integers each irrational root lies between. So, we want to find perfect squares that are inside the square root. In this case, the perfect square would be 4 and 9. We can take the square root of 4 and the square root of 9. Square root of 4 is 2. And the square root of 9 is, do you know what that is? What number times itself equals 9?
3.
Yep. So our answer would be between 2 and 3. So the square root of 7 is somewhere between 2 and 3.
I have no idea.
That's okay. You can just kind of just listen, and if you can help out, that'll be great. So right now this is just for estimating. It's just to help you with Pythagorean theorem. It's nothing that you're going to probably use in your everyday life. So next we want to find the square root of two perfect squares again. So I want to find that are one's above and one's below the square root of 21. Well, that's going to be the square root of 16 and the square root of 25, because 21 is in between 16 and 25. Gabby, do you know what number multiplies by itself to be 16? What times itself? No, that's 8 plus 8. What times itself? 4 times 4,
6?
Gabby. No, 4 times 4 is 16. How about 25? Do you know what number times itself equals 25?
5.
There you go. So the square root of 21 is somewhere between 4 and 5. So it's probably closer to 5. So what two perfect squares does 85 lie between? It lies between 81 and 100. Again, this is where you want to look at your table. And I know I'm kind of losing Gabby here. She's trying, but this is a little bit hard for her. But she's trying. So, Gabby, you remember what number times itself equals 81?
9.
Good job. How about what number times itself equals 100?
10.
There you go.
I'm not losing it.
You're not losing it? You're getting it?
Exactly.
All right. Good job. Probably losing a few of my students. Now, is 85 closer to 81 or 100?
I'd rather say 81.
I would rather you say that too. So our answer is probably going to be closer to 9.1, 9.2, somewhere around there. Okay, so then we need perfect squares that are below and above 45. So what two perfect squares are above and below 45? So if you look, 45 is going to be between 36 and 49. Then we take the square root of 36. Square root of 36 is?
6.
And the square root of 49 is?
7.
Is 45 closer to 36 or 49? What do you
49.
think? Yeah. So our answer is going to be closer to 7.
Yeah.
Okay, do you know what two numbers, Gabby, we're going to use for 56? So look over at our chart, and what one's close to 56? Which two are, one's going to be above it and one's going to be below?
49 and 64.
Good job. So then you take the square root of 49 is 7, and the square root of 64 is 8, and 56, I always miss this one. Every year I always forget, and I don't know why. But this one is closer to 7, just barely.
Barely.
So it's probably like 7.4, 7.5, right in that area. I'm sorry, I'm already moving ahead for number 6. So the square root of 25 and the square root of 36 will have 5 and 6, and that's closer to 6, isn't it?
Mm-hmm.
So it's going to be like 5.6 or somewhere around here. All right. Going to do 2 more. All right, actually, I think we got a bunch more here. So we have the square root of 94. That's going to be between the square root of 81 and the square root of 100. So it'll be between 9 and 10. And it's going to be closer to 10.
Oh, yeah.
By this time, you should be pausing and doing these on your own. I know I haven't been saying that, but please pause the video and try these on your own as you're going along. So for number 8, we have the square root of 18. That's going to be between the square root of 16 and the square root of 25. And it's going to be closer to the 4 than the 5, so we'll circle the 4 here. 2 more. Try these 2 on your own and then see if you get the same answer that Gabby and I get. Gabby's kind of taking a break here. No, you're not? You want to help out? Okay. So what's the square root of 100? What number times itself?
10.
Good job. Now we haven't done the square root of 121. Do you remember? And we've done this one. Do you remember what number times itself equals 121?
20.
No. 20 times 20 is 400.
16.
I think that's, what is that? Like 256 or something. It's actually 11. Okay. So, is 105, Gabby, closer to 100 or 121?
100.
Okay, so then that's the one that we would say it's closer to. Okay, the negative square root of 36, so that's going to be the negative, it's going to be, or sorry, it's negative square root of 39. It's going to be between the negative square root of 36 and the negative square root of 49. 6 times 6 is 36, right? Do you
6 times 6 is 36.
Do you remember what times itself is equal to 49?
8.
Nope, that's 64. So go a little lower.
7.
Okay. And is 39 closer to 36 or 49?
36.
Yeah, so that would be our answer for that one. And I believe these are our last 2.
Hopefully.
Hopefully. You're getting a little tired? Me too. There's a lot of examples here. So that would be negative 7, negative 8. And hopefully you pause the video, otherwise you're not getting a whole lot out of this. So we'll get negative 8 and negative 9. And that's going to be closer, I believe, to 6 out of the 9. I believe the 8. No, closer to 9? That's crazy. All right, that's the end.
The end.
Now, do you remember who I said this was based on?
M.C.
Escher.
Escher.
So this is, I found this font and I thought it was kind of cool. This is based on M.C. Escher drawings. If you don't know who M.C. Escher is, take a look at him, and he's got some cool stuff, a lot of it based on math. Okay, that's the end.
Bye.
Bye.